try to understand how to draw the shear force and bending moment diagram in case of cantilever beam carrying uniformly distributed load and point load. So this is the arrangement, and the cantilever is subjected to the loads as shown over here. So it is carrying a uniformly distributed load UDL of 0.8 kN per meter at a distance of 1.5 meter from the free end. So this is a free end and this is a fixed end, and a point load of 2 kN at a distance of 1.5 meter from the free end. Now, because of this particular downward acting load, the reaction is Ra at point A, and this particular reaction we have to calculate. So first we'll draw the shear force diagram. The calculations are done by assuming the conventions that upward forces are considered as negative and downward forces they are considered as positive. Now, as there is no force that is acting at point B, therefore shear force at point B is 0. Shear force at C right, CR means it is C right, so just at the right of the C without taking into consideration the effect of this particular point load will be 0.8 multiplied by this 1.5. So this is 0.8 kN per meter, that is for 1 meter length the load that is acting or force that is acting is 0.8 kN. So if you multiply it by 1.5, that will be the total UDL load that is acting from B up to point C, that is just at the right of this particular C. And as it is acting in the downward direction, it is positive. So we have considered downward positive. So it is 1.2 kN. Exactly at point C, suddenly there is a point load again acting in the downward direction. So 1.2 plus this particular 2 kN point load. So that will be 3.2 kN. From C to A, there is no other force that is acting. So we can say whatever the shear force that is there at point C, the same will be acting at point A. So shear force at A is also 3.8 kN. Therefore, the reaction that is offered, correct, will also be equal to 3.2 kN. So Ra is equal to 3.2 kN. Now we'll draw the shear force diagram by taking into consideration all these particular values. So at point B it is 0, whereas at C right it is 1.2. So there will be an inclined line. Then there is a point load, so there will be a straight line of 2 kN, so total load will be 3.2 kN. There is no other force that is acting between C and A, so there is a horizontal line, and at point A the shear force is 3.2 kN. So these are the corresponding values which we have already calculated over here. So in this way we can draw the shear force diagram. Now we'll see bending moment calculation and the corresponding diagram also. So for the calculation of the bending moment, we'll convert this particular UDL into point load. So 0.8 multiplied by 1.5 is the UDL load, and allow it to act at the center of this particular 1.5 meter length. So in this way we can convert this UDL into point load for the calculation of the bending moment. So bending moment at B is 0 because it is the end point of this particular beam. Bending moment at C will be due to this particular load, that is the UDL load which we have converted into point load. So 0.8 into 1.5, that is the UDL load, and from this up to point C the perpendicular distance is 0.75. So 0.8 into 1.5 into 0.75, and again it will produce the clockwise moment over here. So as you can see, this will go over here in the clockwise direction. So it is producing the clockwise moment, and we have considered this clockwise moments as negative. So therefore this value is negative. So shear force, or rather bending moment at point C is minus 0.9 kN/meter. Similarly, we can find out the bending moment at point A. So again we will take into consideration the load, that is 0.8 into 1.5 kiloton, that is the UDL converted to point load. From this up to point A, again it will produce a clockwise moment. So from this point up to this point, the total distance will be 0.75 plus 1.5, and the load is this particular load, that is 0.8 into 1.5. So 0.8 into 1.5 and perpendicular is 0.75 plus 1.5, and again it is producing the clockwise moment, and that is negative. So this will be represented by this first term over here. Then this point load, it will produce again the clockwise moment. So 2 multiplied by perpendicular distance is 1.5. So that is represented by this particular second term. So the total answer is minus 5.7 kilometer meter. So in this way we have done this bending moment calculation. Now as from B to C there is a UDN, it is a second order equation. So here there will be a parabola and there will be an inclined straight line, and the values are 0.9 kilonewton meter and 5.7 kilonewton meter. And as these values they are negative, we have drawn this diagram below this particular reference line or baseline. So in this way we can draw the shear force and bending moment diagram in case of the cantilever beam carrying UDL as well as the point load. Thank you very much for watching. Do subscribe to our channel. Thanks.